Got it.
Got it, yes. That's the one. Oh.
We're live.
Yes.
Oh,
Cool.
and it actually says now on the top left, it says where it's streaming to. It's streaming to Twitch.
Okay, that's useful.
All the software features.
It's good to, yeah, now I don't have to go on about we're streaming, but it's still very small. I should maybe still notify people. Yeah. Okay, so yeah, last time we started reproving some Agda in Lean. And this time we're going to continue, but I've made some progress in between stations that might be worth going through first, because and I just did this kind of groundwork so we don't get stuck in a lot of the things that are just kind of a lot of Googling and not actual proofs. And I try to leave all the hard proofs for us to do on the stream. So yeah, but yeah, maybe Paul can share, and then I can explain, and we can, please ask me, interrupt with any questions, right?
Shall we start with a language? Because that's where we ended last time.
Yes.
Is that a good place to start? Or
yeah, I think that's
pick a place.
No, this is perfect. So last time we had this definition of language, and we were kind of going back and forth about module level variables that you can see on line 8. This is on line 8. That's what you can do in like Agda. That module line is Agda syntax. And then you can put the universe as a general thing on the module and this type variable as well. I tried to reproduce this in Lean, and this was a lot of back and forth, a lot. And this, what I got to in the end, is not exactly what you can get in Agda. So I'm actually quite glad Jan is here, because you can help me figure out the difference here. But so we have the universe U that kind of works, and so if you hover over lang, over the def lang, then you'll so you can see U is there as an implicit arg in the curly braces, and then the type level variable alpha or A is now not implicit, it's explicit. The problem with making it implicit, which I think is what's done in the Agda case, is for empty set on line 25, we cannot infer it. So, like,
because there's nothing in here.
Yeah, so we end up
in the body
at lang and alpha to provide the implicit argument of alpha. So I opted for not making that implicit. But on line 21, I opted to make all the rest of the constructors implicit. So
how do these interact then?
Yeah, so
this one and this one.
Yeah, that's a great question. So the one on line 21 overrides the one on line 10. So it kind of executes in order, right?
Right.
Yeah, there's a way to make this much more understandable by not doing line 10 and just writing lang as a parameter alpha, but I wanted to kind of stay close to the Lean, to the Agda, but we can change it. And then, yeah, but you don't want empty set and or and all of those to have an explicit alpha, right? Because that's super annoying.
I just this is another thing I forgot last week. We can actually just run
Yeah.
hash check lang, and it actually gives you the type.
Mm-hmm.
Or you can hover over it. Oh, I didn't want to do that.
Yeah.
But yeah.
Yeah, so basically if you go to lang and you
Yes.
just add alpha as a parameter there.
Yes.
With type U.
Yes.
Well, yeah, exactly. Yeah, take the first colon away.
Oh, yeah.
Yeah, if you do that and you remove the variable on line 10.
So here's a question though. Why does this work now? And with this variable, does this variable get inserted in here?
This,
I think it's shadowed.
It's shadowed. Oh, because it has the same name.
Yeah.
Yeah.
But if I said beta or something, it wouldn't work. Okay.
Yeah. So yeah, so you can remove that, and that's the same as it was before now.
So this universe also applies down. Well, it applies
Yes.
here and so everywhere else.
Yeah.
Okay.
So basically, there's no magic. It's just a shorthand.
But what it when you say variable, it just inserts this argument in every definition.
Exactly.
Okay.
I think it's in every definition where alpha appears.
Oh, okay. That's
But
that's the bit I was missing. So you could write something else that didn't involve alpha, and it wouldn't get this argument inserted.
yes, I think so.
Yeah, I wasn't so clear from the documentation because obviously so I've had def foo. Don't know what have I got here. Or string. We had string, right?
Just the empty string.
Yeah. But it seems now check the type. Oh, it's not working. Yeah, so it's just a string that doesn't get added as an argument.
Yeah. So yeah, Jan is right.
Okay,
it's only inserted.
That's good.
It is used.
So you just have to remember this rule then, because it wasn't clear from the docs how this should work in. Because you might have other stuff here which doesn't involve alpha, and then you've got to what you got to do. You got to close the namespace and open it again or something. But that seemed a bit strange, but this is good.
Yeah, that's a good point. And also, technically, if you remove line 21, nothing changes either. Because everything that has an alpha will implicitly add an alpha.
But the callers of these things will be broken because this is implicit.
No, but like if you look at line 25, like do a check of empty set.
So why is it implicit now? Oh, hold on. Yeah. So it's, sorry, I thought this was here. No.
Now you will break it.
Yeah, now the callers will be broken if they were using implicits. Okay. Right. So this is adding the implicit argument because this alpha's here.
Yes, but that is what Lean does automatically anyway.
So does it do it because it's a Unicode letter, or like why is this? I think I remember it used this for Unicodes, but maybe I'm wrong. No, I'm wrong. Okay. So you never have an out of scope here. It always generalizes over type.
Yeah, make a longer name like ABC.
Oh, this. Sorry, this one here.
Yeah.
And this is now.
Yeah. Okay.
Generalized.
Interesting choice.
It is well, okay. Maybe they should have only restricted it to some characters, but it is very useful to keep definitions limited to a number, like a certain size. Because like in Haskell, you wouldn't write, "Oh, I'm passing alpha as a type," right? You're gonna go.
Unless you were saying like for all.
Yeah, you're not gonna do for alls either.
No,
it's all implicit in parametric polymorphism. So this makes it a more practical language.
Mm,
and
yeah.
not it's a dependent type language.
Although I would say if you have the variable mechanism, this can help you have short definitions without, possibility of confusion over unwanted generalization.
Mm. Yeah, but once you start adding like A, B, C,
yeah,
yeah,
for like an F map or a zip width or something, then yeah, like other languages don't require this, so it's only because we're doing dependent types. So this way it's kind of like this is more parametric first, and then you want dependent types, we'll go for it. Like nothing in the syntax is holding you back, but we're also not. We're gonna assume you're just gonna do normal Haskell stuff. But yeah, it is definitely a design choice. Yeah, so I was so this is now for Jan here. Like, you can please criticize. I was unable to define lang without requiring like empty set and or to provide to say like lang alpha. So if we look at the Agda file, you'll see like okay, cool. Perfect.
Maybe I could even have them on the same screen. I don't know. Let's try it.
Yeah.
We
We could also just look at the comment in the lean file. Maybe that's actually fine.
How can I get rid of this panel here?
It's okay. You don't need to. You can just
okay.
full screen the lean again. I see.
Yeah.
I added it in the comments.
Oh,
so
great.
See, like, on line 23. You see, that's the definition of empty set is only lang. But
right.
I have to say
alpha
for in lean. And yeah, so this is where like the A in Agda is like much more powerful than the like this module level type is much more powerful than the lean one. It does a lot more inference. But I'm hoping it's at least equivalent in terms of expression, like what we're expressing here.
So in the Agda, this
yes,
you have this module. Sorry, where's the variable?
just after the module name.
Line 4.
Oh, this here.
Yeah.
Okay.
So this
How does this A get to the? Oh, it's this. Is specifically this one.
Yeah. So in Agda, when you have parameters to the module, they are accessible, in the module body in every definition.
Right.
But this is slightly different in Lean because you have this implicit quantification inserted in every function that uses it. But from one definition to the other, you don't know that it's the same alpha in Lean, whereas you do in Agda. So that's why you had to specify the alpha explicitly in Lean.
They're expressing the same thing, right? It's just more convenient notation, or is there a difference?
When looking from outside of the module, they are the same thing.
Okay.
But inside of the module, it's basically the same thing, yeah.
Okay. All right, cool. That's a relief. Yeah, so I couldn't get it to be as convenient as the Agda, but yeah, from outside the module, it should be the same.
Yes.
That's at least, that's the intent. Otherwise, I screwed something up.
So one thing that is very useful with module parameters is, let's say we want to use this module like from somewhere else. And then you open it. Well, I'm not sure how you open modules in Lean, but there must be some way of doing it. So in Agda, you can
So
provide
something like this.
Exactly. So you could say open language and give it a concrete alpha. And that would be, you know, like implicitly applied to all the functions in that module. But if Lean doesn't have module parameters, you will not be able to apply the alpha to every function. You'll have to rely on inference to guess it on every call site.
Okay. That makes sense. I'll keep looking, but yeah, I think this is the best we can do. But yeah, I just wanted to at least be sure I didn't break the intent here, so that's good. All right, so then the next interesting thing is p-empty. If we look at empty set, last time we used empty, which if you scroll up a bit in this file where you are.
Sorry.
Oh, no, in the file that you jumped to.
Yeah.
That was perfect. So right there, you can see empty is on 195.
Yes.
And yeah, 202 is p-empty. And the only difference is it actually allows you to specify the universe, where 195 doesn't seem to. So that was
no, it says 0, I think.
Yeah. So it always has to be 0. And
this one, sort 0.
Yeah, so prop. So yeah, so this is in the prop and type things are different. But sort is kind of both. So actually, this was a great way to explain it. Is prop is sort 0. Type is sort 1. I think if you hover there, it was giving you.
Yes, so it says type is type 0, type u equals sort u plus 1. So yeah, it's a roundabout way. It's telling us that type 0 is sort plus 1.
Yeah.
Sort 1.
You can have levels of type or sort, right? But prop is sort 0. It is not a type. And type is sort 1. And then from then on, all types are sorts.
I see. Okay.
Yeah. So
it's like shifting this by 1.
Yeah.
So you get to have, this is like type -1 or something.
Yeah. So all types are in sort, but
yes,
not all sorts are in type.
Yes.
And yeah, so I didn't need sort 0. Like, I don't want sort 0. We don't want that. We only want type sort 1 and up.
Yeah.
But p-empty is still the best way to get just the type of any universe. And since we're specifying universes, this is why we needed p-empty instead of empty. Like, the other thing to do in languages, we know we actually only want type 0 and type 1. But since alpha can be in any type universe, we do want that type universe and type 1. That type, that type plus 1. So yeah, but we know alpha will be in type 0, which I think type 0. Well, no. Okay, I'm not gonna go with the comparing this to coq, because then
yeah,
this is the best I can do today. And as far as I understand, set in Agda is type in Lean. That's my best
I think so.
guess.
And also, I think that, or maybe I'm wrong here, but in cubical Agda, I think they are renaming set to type. So I think they want to adopt the type nomenclature. I think I might be wrong.
That's great news, because yeah, set in coq has very special meaning, and
yeah,
it's okay. That's very good. All right, so we can go back to language. P unit is the same, it's just unit, but you can specify the universe. And if we scroll down, just checking.
This is just notation for what we had before. This
yeah, let's
equals.
go there. So I think like this is, yeah, perfect. So this is the type file we had lost, the type stuff we had last time, but now like made it possible for us to use REFL and all of these things. So we have TEQ exactly like we had before. It's just equal for types, or equal that returns a type instead of a prop. Then we have an abbreviation for equal, which is just for typing if you want to type it with a keyboard, then you say /equal.
Right.
Then you get triple equal. Okay.
So just one thing, was there a version of equality for sort? Were we just looking for the wrong thing?
I had discussions about this, but yeah, I don't think so.
Okay. Yeah.
Yeah, so we have to do this.
Okay, great.
Yeah, but we can get reflection with line 20, so that's kind of neat.
Yeah. So we haven't lost an awful lot.
No, we haven't. Like, well, there's more that I will tell you that we've lost, but I think I've read on most of it, but like let's yeah, we'll see. So yeah, then you can see on line 22, you can do a REFL for the type equality. So that's the REFL tactic.
Yeah.
If you want to use the REFL function, this is redone and now called trifle instead of trefl, because it's more fun this way. Happy to take the fun away and rename it. I don't care. I'm going to start out with something fun. Yeah. So this means you can just call the function trifle instead of using a tactic. And as you can see on line 27, like we don't need to use by, we can just call the function trifle, just like we call REFL in Agda. This, we'll probably use this a lot.
So
but does REFL do anything else? Oh, yeah, sorry, go on, John.
So what's the difference between trifle and the constructor REFL from TEQ?
Well, then you have to type TEQ.REFL, and this one has slightly better type inference.
Okay.
That's it. It's very low. Like, yeah, it's, yeah, oh yeah. So actually you can see so on line 12, you can see TEQ takes the alpha, the X, sorry, it takes it explicitly. And on line 25, you can see that it takes that A should be an X, like, but it takes it implicitly.
No, but REFL takes the X implicitly.
Yeah, so this REFL here has the same type as trifle.
Okay, let's make an example on line 14. basically the same, just
one.
yeah.
Do I need to qualify it?
Yeah. Yeah. And yeah, maybe below line 18, sorry.
Oh yeah. Not
my bad. Yeah, okay, it's the same. But I don't like typing TEQ. I think that's my problem.
Okay.
Yeah. That's a good point. Very good. Let's don't delete that. Let's commit that. Okay, so next, on line 33, I had lots of discussions. And yeah, if you look on line 38 to 39, that was going to be this definition, and it looked really good. But when I started proving things about it, it started breaking.
okay.
Yeah, so I had to revert to what we have now on line 33 to 35, which is the same as we have in Agda. I was just hoping we could get something nicer.
So this is the same. Well, this is the sigma.
I think this is the pi type.
Yeah.
Pi type. Okay. Yes.
Yeah, the thing is, you can't do cases on this all. So if you have this as like a hypothesis, and you can't destruct it because the technique only works on things in prop. And yeah, we want to be in type, but
oh no,
you can very easily
going to become a theme of this.
Yeah. No, definitely.
Yeah.
But yeah, on line 33, you can use type, and cases works fine. Yeah, all works perfectly well if we just do that. But yeah, slightly more inconvenient. But to the user, it's actually nicer. Okay, so then line 42 is just not. And here I'm using empty instead of p empty. And yeah, I don't have a good reason. Except I can't use PM here. I know that doesn't work.
Okay.
I can't remember exactly why.
Yeah.
So this might be a problem. Then yeah, this is just if and only if. The next stuff. And then I added I copied and pasted the notation and gave it a higher priority than the prop stuff. So that even if we include the prelude with this, it's not a problem for us. Just don't import this file if you want to use prop. Which I think is fine for our use case. Yeah, so and then I can just quickly, there's tdecidable.lean. So we don't have to go through this. So it's just a copy paste job of all the decidability stuff in the prelude, just turned into type instead of prop.
Okay.
So we'll need this probably next week, or 2 weeks from now, or no, then it's Christmas. So we'll need this in future. But yeah, don't worry about it.
Okay.
I don't know what
So
it is.
I find it intriguing that they only have this for prop in the prelude.
It like you. I think it's this philosophy of like the proof is irrelevant, right? So why would you have this for other type universes? This is
Well, I mean, the proof is not always
if you believe
irrelevant,
the
right?
proof-
That's the main thing about the paper we're formalizing.
Yeah. So if you believe that the proof is irrelevant, right? Then you use tactics. You have prop where you're going to throw away everything, and you build your infrastructure around prop. And if you don't believe that, then you don't have tactics. And if you believe the proof is relevant, then you don't have tactics and you build everything around type, I think. So yeah, very like, yeah, it is strange that they don't have this, but it's also not strange because they've bought into the philosophy.
I see.
Yeah, so we're gonna run into having to redo all of this all the time, but luckily there's not too much to redo, and the Agda paper shows we don't need too many tactics, so we'll see. Yeah, it is annoying.
I don't know if
when
this
you
is
that all of this could have been defined on prop or type and would have been fine. Like we could have been enabled, but we aren't.
I don't know if this is intentional, but I like this.
This
Tis true, tis false. As in like
yeah. It's true.
Yeah. It was intentional?
No,
Right.
no.
No.
I typed it and I was like, oh, this is beautiful.
Tis true. We can't do that.
No.
No, actually, it's this, isn't it? Yes.
No,
we can't do that.
Update the constructor, but I don't think that character is allowed. You update.
I'm going to disallow it.
Yeah. We can make notation for it. It's fine. No, it was totally unintentional because I was just adding a T in front of everything, and then I was like, "Whoa,
yeah,
it worked out very well." We've got trifle and tis true and tis false. Okay, so now we can go back to the regeg stuff.
Oh, we've seen this. Yes,
it's not interesting. Like, yeah. Okay. Yeah, let's do language notation. Yeah.
Rebuild.
So this is just some notation like we have in Agda, and I should have copied the Agda lines here. I'll do that next time. So the differences is like in Agda they had a very nice U for universe that I couldn't find. So if we find it, let's please change it. And then,
it's like mathcal U or something.
Yeah.
Do they have like cal U? No. Mathcal. No. I don't know.
Yeah, but
if someone the LaTeX word.
So if you paste the Unicode symbol in Lean and then you mouse over, does it tell you how to type it?
Oh, that's a good point. Paste this in. Yeah. Oh, MCU. Yeah. So it's mathcal U.
Yeah. Can you do that? Try that.
Yeah, mathcal U. Oh, mathcal capital U.
Oh, nice.
Yes.
All right, let's replace it now.
Oh. U. Oh. Not very good at typing these things. No.
Okay, and also make the note there, please. Capital U, right?
Oh, sorry. Yeah.
Yeah, cool, thanks. All right, perfect.
So there's not used anywhere, is it? Or...
Well,
It's just in a comment.
Yeah.
Oh. Oh,
In
here,
those-
yes.
Yeah. And then 27 and 28.
Oh, yeah.
I think that's it. Yeah.
Yeah.
Cool. And the other one that's weird is on line 10. So in the Agda, we had a backtick and then as a character, but yeah, we can't use any ticks or quotes.
Yeah, I think backtick is reserved, as we can even see from this, right? This
Yeah.
quotation thing.
Yeah, so since we couldn't use any quotes or any of the characters that are associated with characters, I've chosen some curly braces, but I'm very open to changing it. This was just... So the thing is, shouldn't just work for character, it should work for any... If we use nats or anything. So just... Because the place we use this notation is in proofs, and there it is important that this could be any type. But yeah, so that's open for anyone. Then like line 13, I definitely have the wrong infix notation because I am unable to use it anywhere. So I need to play around with infix R and different priorities to make that work, because currently it's not working. For concat, I chose comma because I don't know. Yeah. I like it. Yeah, that's it. It works.
Is this just a normal asterisk character? Okay.
Yeah.
Good.
Yeah. Oh, yeah. We can change that, but
oh no. That's fine by me. It just looks kind of fancy in this font.
Oh.
Like I'm sure there's like a fancy star, but that's so small. Big star.
Oh.
We'll need that.
We'll need that.
We'll need it.
And then in the below lines, this commented out part, you can see how it's used.
Yeah.
See, the characters are kind of annoying to type. But then you can also do numbers like on line 35. The rest looks okay. And you can mix it with actual like types. You don't have to always use notation. So like on line 36.
So the braces create like a singleton language, or what is this? The meaning of the braces?
I don't think all the braces are needed, but I'm really bad at picking priority names. So sometimes I overbrace. That's definitely something I do.
Right. No.
I think you're talking about the curly brace.
Curly.
Sorry. Yes. Yeah.
And also braces was the wrong word as well. So just from how I used it, because it was parens and the braces are square. So
oh, okay. Oh god. Whoa. So braces are square? What are these? These are curly braces. Okay, curlies, and then these are parentheses, parens. Okay.
Parens.
Oh.
You just want to say short names, then.
I thought brackets were square and then braces were curly. Okay. Now
that's what I thought as well, but
no, maybe you're right.
Okay. What are these? These are angle brackets.
Yes.
Yeah, I don't know. Good name. Okay, but I need to go read.
Anyway,
right. So what my question was, when you put something between curly braces, that's a singleton language.
Yes.
Okay.
Well, only contains.
But how does this work then? The numbers. Because these are chars, because chars are just integers.
Yeah, so
Oh,
now
That's why
you're
this works.
you're in language net if you do that. right?
yeah, so alpha is inferred to be not.
Yes. Exactly. For that language down there.
Yes.
The others are in lang char.
Right. So
But
when
then
we
how
use
does this work?
so when we use lang.char, it's not restricted to the char type. This is just this, as far as I understand it, prints the singleton language for
I'm sorry. Yes.
given an element of some type.
Yeah.
So it's a language that only contains that one thing.
Mhm.
Okay.
But char is a bad word as well. But yeah, singleton is actually nicer. But yeah, we use char since we're in regex land, I guess. But yeah, singleton is actually better. But then, yeah, empty string is also a singleton language. That's the other, just for fun.
Yes.
Yeah, this contains a language that only contains the empty string. So,
Yeah. So if you use the word singleton here, then this
Hmm.
becomes confusing.
but it's better than char. We just let's keep spinning. Let's keep rethinking that. Yeah, so that's what happened. We can go to regex notation.
Oh, yes.
There's another way to do it. Like as if that wasn't good enough. But in this case, if you go, let's just go down to the bottom. I think there's some checks. Yeah, so here you can see some examples of it being used. So you can say, I have a regex and it is the empty set. Or so you basically start with a parenthesis, regex pipe, and then you type your notation, and then you can close your paren. And then you're in this notation where you have much more parsing power than we currently have, which means like on line 122,
Yeah,
you can just write a character.
Yeah,
like we don't have to put ticks, we don't have to put curlies, but everything in regex is in lang char, so that's assumed. So we can't use this for like proofs, unfortunately. And you can also do matching. So if you see like on line 118, sorry, then you see empty string matches the empty string, and then you can just prove this. Yeah, so this is nice, but it only works for regular expressions, and yeah, it's not generalized over any type. So it's kind of, we'll probably not use this, but this is the reason language notation is in a separate file from regex notation, so that you can actually choose which one you want to import.
Yeah, so this is where you have access to all of this elaborator and quotation gubbins.
Yeah. So you get a much better syntax, but we can't really use it. Yeah, unfortunately. But it was fun.
Yeah.
And a good example for anyone else who wants to build a language. Okay, now we can go to examples. So here I've finished all the examples from the file examples.lagda. We can see on line 16, I'm actually using trifle instead of teqrefl. And on line 28, you can see an actual use of refl, like the actual refl tactic being used. And then, yeah, the line 37, this is a new proof. And you can see how close it is to the Agda proof on line 34. Is basically equivalent. So that's good. Except we needed sump. So if you can go to line 36 to see this, the lean info view on that.
Yeah.
And then yeah, just see what sump does. So maybe you can give us a little bit of a wider info view.
Mm-hmm.
Yeah, so we have this, the regular
Projects.
expression mech. But then we need sump to take all these constructors away. So if you go down to the next, yeah. And this looks confusing, right? If you look at this, we have several equals in here. And I was like, what is going on here? How can we prove multiple things are equal? But so this is where parens would have been useful. The crosses are, the product is important, right? We want a list of chars, then we want another list of chars.
Mm-hmm.
Then we want a proof that a char of 97 and 98 equals x plus y. Then we want a proof that x equals a singleton list of 97, and then we want a proof that the singleton list of y is 98.
Looks like the highlighting is helping me. If I hover over this, I expand this bit, it expands to this part.
Nice. That is nice.
And then this is this. I don't know if that stable part of the the info view API, but it does seem to.
Yeah, that's very cool.
Reflect this. So what are these the angle bracket thingies? Oh, yes, I forgot. These are the dependent pair constructor.
Magic constructors in Lean.
Yes.
So in this case, they're prod of prod of prod of prod of prod. But yeah, very useful in this case.
Yeah.
Because you don't have to go prod make, prod make, prod make. Yeah. And if you go to language.lean again, sorry to be talking so much. At the bottom, I think, yeah, they're like on line 80. You see, we made all these constructors, things that the simple tactic can take away for us. But yeah, like, I wonder, can you change that simp to REFL? Yeah. Okay. No.
Yeah, it has to be.
Yeah. Okay. No. So you have to
like
have
that.
Yeah. So we go back to the examples. Yeah, we do need that sum. We can't, like, if you take it away.
Yeah.
Oh. Okay, now take away the take away the by and the exact.
Nice. Okay, this is. Whoops.
Yay. Okay.
Don't need them tactics.
We're doing Agda now. Nice.
Just new line it.
Yeah, new line, please.
Yeah.
Nice. All right, now they're exactly the same. There we go. Okay. And then, yeah, so these were just prep work for the next example. If we go down, see here. This is the next one we needed to do in Agda. And yeah, it's not the same. We're close. But yeah, what's nice is the refine tactic. So this way we can start like partially constructing something and then say like, okay, question mark A, this part I still don't know. So I basically I can construct the first part of the product, the first element, and I can say, okay, there's a bunch of more of this product type left, but I'm just gonna add in one, and then on line 62 I just add the next one.
Nice.
And
yeah,
then
this is not, because in Coq you can do this with like
underscore.
Yeah, or like apply or something. But you have to be, you can't be as explicit about what is missing.
Yeah. Oh, okay. I think you can. I think you just put underscores in.
You put underscore.
Yeah.
So is there a refine tactic in Coq that
Yeah.
allows you to do the same thing? Okay. I just can't remember.
Yeah, we need to add it to the cheat sheet. Yeah, then if you scroll down.
So I have one question. If we remove the simp at line 60, does it still work?
Yeah.
Yes. This may have been to help Walter figure out what to do as well.
Right.
That's the other thing.
Okay,
Okay.
but let's keep this the long one. Just scroll down. Like I made an alternative here.
Okay.
So we can try to shorten this one.
Yeah.
Maybe the simp is not required here.
Yeah. And then
And
so we can do
exact as well.
Also.
Yeah, exactly. We can remove tactic mode in this. But you may have needed to know, you may have needed the simp to figure out what to do. I don't know.
Yeah.
That could be the other thing.
Yeah, I couldn't figure it out without it.
Yeah.
So it's funny because to me, the example at that line 59, it's like a log of what you would write in Agda.
So you might like do some key combinations to make a whole or something.
Exactly, and then write ABA and leave a hole there, and then press the keyword for not the keyword, the key binding for refine.
Yeah.
And continue well, to follow these instructions basically until you have what determine line 65 onwards. I think here it's quite direct translation between tactics and commands in Agda.
Yeah, but this is a special case for how I did try to use the tactics in this way.
Okay.
But,
makes sense.
That's not a exact how a lean program would use it, but I also couldn't do it. I couldn't write the one on line 74 without doing it this way first. And I also wouldn't have done this. I didn't know how to do this differently either. So like, it's just if I was in prop, I think it would have been different. I don't think I would have done apply all.cons, for example. Like that's the one I think where things would have been different. But I don't know. And like, yeah. It is the first time I've used refine in lean. But now I'll probably use it a lot in this project, I think.
So is there a command to see the term for this example? We can't refer to it by name, can we?
There's definitely a command. I don't know what it is.
Like if I
print?
Like check it, it's the print. It's not going to know what I'm referring to now, is it?
You can make it a function.
You can give it a name.
Oh yeah, I forget.
Or that.
Right, so it does. Have we somewhat? You squint, you can see this.
Yeah.
Yes. So we have the first here, which is just this is just for the
product.
Yeah, the dependent pair. This is just the angle bracket syntactic sugar has been removed. Okay.
Yeah, so it's pretty close to. Yeah, it's very interesting that your workflow in Agda is the same as someone using tactics in Lean. But you end up with something that's more reproducible on recompile, I think, with different versions of Agda. Where if you use tactics, there can be a lot of churn on the tactics change a lot, and then it does with different versions of Lean, and then you have to go reprove things. Or I think if you use the method on line 74, there's very little chance of you needing to reprove something. And this is what you would end up with in Agda after using the workflow on line 59. So you kind of get you get it. There's a pretty good place to be, I think.
So have you considered defining an infix constructor for cons?
I've considered it. I couldn't think of what to use. Triple colon.
Well, that is Unicode double colon.
Yeah. Yes. This is what don't we still have this in Juvix?
No. We
got rid of that.
Yeah.
Oh no. I am open to it.
So
I mean, it doesn't need to be that, but I think making it infix helps.
what? You can't type it like that? I thought that's how it was typed.
You have to.
In Agda is typed like this.
Okay, so I need to do the old copy paste.
Yeah.
Oh, now I need to set my input method. Okay. Right, you are a. Oh, it is that. Okay. It disapproves. It doesn't want us to. It doesn't want us to use this. Oh, I have to press space.
Yeah, you have to press space.
Okay.
Yeah.
Looks like a dice or something.
So I don't think you can do that. You have to type cons there, but then you can use. You see the infix stuff at the bottom.
Yeah.
Let's do something like that.
I know. Well, we can see what Agda does, I suppose.
But it should be infixar.
Oh yeah. Deal what number?
All those cons.
Oh yeah.
And you have to have spaces on both sides of the.
Oh yeah. So it's like
depending how you want
notation.
Depending on how you want it pretty print.
So if you want to use the constructors unqualified, can you do something like open all?
Yeah, I think you can do that. So if you say open all, then you don't need to use them qualified, or open some or whatever.
Okay.
So yeah, which we would want to do here, right? Because I wouldn't want to type all dot double.
Yeah, no, but I don't think you need to do that for notation.
Oh, of course, yes.
Yeah.
So here I would type this. Does it work?
I think you might need to restart your IDE.
Click all the buttons, make it go away. Oh no, that's
Yeah.
list, isn't it? No, is it working?
Yeah.
It is okay.
Whoa, look at that. Whoa,
We
whoa.
just need the
Oh, it's
infix. Yeah, I'm eating all the parens.
No. Now you made the wrong.
Did I?
You made the wrong colon. That's all.
Oh, I did. Okay.
Nice.
It doesn't have support all of Vim.
Yeah.
Okay.
So are we happy with the null there at the end? Irritates. Fuck.
Well, now we need more. We need more. We need to hack the elaborator in order to get our own less literals.
Oh, I guess we could do Unicode for open bracket, closed bracket. Like,
Yeah.
but like maybe it's good enough.
Where did this come from even?
Type.
Type.
No.
Yeah, I don't know.
Like the Agda just had the empty list at the end, but we also have
Okay,
lists.
maybe we just do that.
Um,
But are we allowed to do that though? I don't know.
let's see.
And these numbers are obviously wrong.
Yeah, that's like.
Well, but it shouldn't be an infix.
Oh, I'm sorry.
It's just
Thank you.
I think we just say notation.
Mm.
Get away with just saying instead of infix or just saying notation. Priority is still good. Give a 29 or whatever. And then you need to restart.
I need to do the restart. Okay, that's a bit sad. You need to restart.
Yeah.
Okay.
Click all the click. Oh, something exploded.
Mm.
We got a C.
I think there is conflicting precedents.
Yeah.
So try to give it maybe no precedent is good for the nil.
Yeah, let's try it.
Oh.
Okay, so that. Kill it. Red means
Oh.
bad. Okay.
Yeah. Okay, so it needs
no, yeah, look, it's confused now because this is obviously
Hmm.
the wrong thing. I think we
Okay,
just put it
maybe
back.
in no wait in a language. Wait, in here. Yeah, here. Space after notation.
Yeah.
Say space for open parentheses priority colon equals low.
Low.
And let's see what happens. I don't know why there's two ways to indicate priority, but
Is this from before or from now? I don't no
I
idea.
think you've got open language.lean and then we know because the error is happening in language.lean.
Oh, sorry.
Yeah, no,
Oh.
the other. Like in language.lean.
Oh, I'm in the wrong. Sorry, I pressed the wrong
This
button.
one. Yeah, there we go. On
I don't even see where the error is. Oh,
Yeah.
here it is. Yeah, so this one is he captured the wrong thing.
yeah.
Thinks it's
So I'm wondering, is there some Unicode open and close brace?
yes, I'm sure of it. No, lost type. Don't know what have we got here. And this one with Unicode.
Maybe overall and the open bracket, close bracket.
Like this.
Oh,
Why not?
I can live with that.
And well, yeah. So is the double colon, the Unicode colon, not used by anything else in Lean?
Not by anything we care about.
Ah, okay, then it's fine.
Yeah, but yeah, because we use the Unicode double colon, and yeah, list uses plain double colon, but list uses open bracket, close bracket. So we can't. But yeah, it's too hard.
Right. But we can't use this.
So the for all open, close open is
Yeah.
fine, and then
Okay.
maybe a little to do on the line above. Find a better
Yeah.
symbol for this. And, then we. I think it's kind of, yeah, one person just struggling for an hour to figure it out. It's not. Let's not bore ourselves here.
Okay,
Cool.
maybe this works now without the scary
Yeah.
the stuff. Okay, it's happy.
Okay.
So how close was this to the Lean to the Agda? This
You can see it's
just the same.
Very, yeah.
Mm-hmm.
Looks very similar now.
Yeah. Yeah, so they just have ing1 and ing2 for their sum type, and
yeah,
that's the only difference. So I'm happy. But yeah, I'll keep both there because it's interesting to see the difference.
Yeah.
So then the new work is all in calculus.lean.
Yeah.
I got
something's broken, is it?
Just the use, I think. To use all the places where I used universal. Remember we.
Oh, okay. Yeah. Can you find a replace on that?
Yeah, that would be good.
No. Yeah. And then I need to type. I don't think I can't type in here, can I? No.
No.
What? That looks different.
That looks very different.
Hold on. Let me try that again. MC. Ah, right. No, it's bold. MCU. That's it.
So
Okay. Now, well, how do I actually action those changes?
I think the little button right next to the second text box.
This one.
Yeah.
What the hell is that? Oh, okay. Whoa.
Yeah. No.
No? Well, how do I undo that now?
So this file is fine. You need to go back to,
Well, that does it in the whole project.
I think regex notation is the one where you need to go undo, but or not. Fuck it, why not?
You can't do this.
It's fine. It's probably fine.
Oh no, look, it's not changed.
Yeah. Okay. Cool.
Right, let's just go back to calculus.
Yeah.
Does it work?
Now it should all be fine.
Go away. All right. It seems happy.
Yeah. So this is all the proofs we need to do. So some of them, the REFL ones, I've kind of done. Ones that are just REFL. But you can see here, like this one, I've not done.
Okay.
So yeah, we can take a look at that, but maybe let's take a 5-minute break.
Oh yeah.
And then
See you in 5 minutes.
yeah, then we can take a look at these proofs. Now that
Great.
it's caught up. That didn't take long at all. But yeah, you had good questions and good improvements, so thanks. Okay, see you soon.
See you in a bit.
Ooh.
Oh,
Hello. Cool. We're all
Hi.
back. Yeah, so when I look at this Agda proof, I'm kind of intimidated, even though it's very simple. Like, just because it's 4 lines and not ReFL like all the others. I think it should be easy to prove. So, do you guys want to try?
yeah. Let's give it a go.
Like, maybe starting with using tactics and then seeing if we can do it more Agda style.
Maybe do Agda style with tactics. So, like
Sorry?
what you would do in Agda,
Hmm.
but with like the refine tactic and so on.
Okay. Yeah.
So what would
Hmm.
So do
what
we
is
have
the
this?
descriptor of this thing?
So sorry, Jen.
I just wanted to ask, do we have this MK double arrow built in?
Yeah, I think it's
The constructor of the if and only if.
yeah, we need to find this.
So TIFF,
Oh yeah. Tough
so intro, TIFF.intro.
Yeah.
So can we do that refine?
Yeah. We can say refine.
Refine.
Tough intro. Oh. Question mark A, question mark B.
Yeah.
Yeah.
And we've got 2 unsolved things.
Yeah.
So it's giving me B. Oh, case B. Case B.
Yeah, with case A and case B, you just you can all messages you can collapse if you want. Yeah.
Just give me B.
The first
B
one
and
is
then
A.
B.
No. Collapse all messages. Forget about that.
Yeah.
See, the tactic state is 1 up. There we go.
Okay. So this is A.
Hmm.
Yes.
I mean, messages is enough. We don't need all messages.
Yeah.
Yeah. So now we're in case A. We can do backslash dot space.
Yeah.
Yeah, and then we're here we go. So case A isn't this what we had?
Yeah. What's gone on? Something odd has gone on here, right? Because we've ended up in. This is what we want to end up here.
Yeah.
But the dot has not done that.
Okay. Okay, so maybe let's not do the dot. Maybe let's just do case A. So intro.
So this is the. Yeah, this is new of epsilon.
Yeah.
Okay, so that is part of the definition of epsilon. So.
Yeah. Just H, whatever.
Yeah.
And then
and then new is this is just
yeah, and if we pass
empty
string, I think this might just be simp.
Right. I've lost where I was.
Yeah. So like simp at h. Nothing? Whoa. That's... Hey, what about we add attribute sump to nullable?
Yeah, to nullable. Okay, that is in.
I don't know, language have examples of how to do it.
Let me just find nullable.
Okay.
And then we need. What do we have? No.
In language.
Oh, in language.
We have examples.
Language.lean. We had something. So attribute simp.
Yeah.
And
Calculus.
Calculus, sorry.
I don't know. It's hard. Yeah,
Would you
we
put it? Oh, we need to put it above where we're going to use it, though, I suppose.
Oh yeah, we can do it there, but we're also going to do it for derive, right?
Ah, okay, yeah.
I can't imagine we're not doing it. So it's such a simple unfolding. Like we do want to just be able to unfold it with sump. Okay. Yeah.
Yeah.
But actually, we don't even need to do that. Sorry. All the goal wants is p unit, so we just have to construct.
Oh, we could have just provided that, right?
So we do
Because
intro
p unit,
and then just p unit dot something.
yeah. Well, we just want exact.
Yeah.
P unit.
Unit. Yeah.
We.
Yeah.
But this is not what we would do in Agda. So what would we do in Agda? I don't know.
Ken, how would you?
I'm just following what this would. So you would write MK arrow, and then you would do refine or something.
Yeah, well, I can. I propose that we do it in Agda first.
Okay.
Because I think it's. Yeah, I think it's going to be interesting.
Okay. So there should be calculus stuff like that.
And then I need to find this one here. Right.
So just V1.
Yeah.
Yeah, the
How do you meant to search for these things?
Without a space.
I'll put a space in?
I think so,
No.
maybe.
Ah, there we go. Yes.
Okay.
So let's comment this out. Ugh. Okay, I've messed up. Oh, it's because I need to give it a definition.
Yeah. So you write B1 equals question mark.
Right. Great.
Okay. So then you start with refine. I think it's comma R.
Oops. Doesn't look like what I wanted. Was it?
I mean, we can start. Well. So what is this MK double arrow prime? I guess it's
the constructor of the if and only if.
Can we go to it?
Yeah, you give like
right
functions and then the proof that they are mutually inverse, and then you get a proof of the if
Yeah.
linear.
But this is not really a constructor, this is a function. I thought this
Okay.
would be a constructor.
Yeah, because
Okay.
the MK.
Yeah. So then we can copy this function name.
This MK
Yeah.
double arrow.
And then you paste it inside the hole.
Yeah.
And then refine in normal mode.
Okay. Yeah.
Okay.
Right. Then we go to the first. Oops.
Mhm. Yeah.
I can't tab to the. How do I go? How do I navigate between holes?
Command G, or I think there is next goal and previous goal.
All right. Let's just check. Next goal. Yeah. Comma F.
Comma F. Yes. And then.
How do you go backwards?
Comma B, I believe.
Previous goal.
Try comma B.
Oh, sorry. Yeah. Or forward and backwards. Yeah, that
Yeah.
makes sense.
Okay. So then you press refine again.
Yeah.
So comma F to go to the next goal.
Yeah.
And refine as well. Oh, lift. Interesting.
So refine is doing a search, is it, of stuff that might type check?
As far, I mean, I cannot really provide a detailed answer, but as far as I understand it, it's like if you expect a function, it's going to introduce a lambda. If you expect something that only has one constructor, it's going to use that constructor.
And then down here, it's giving us some info. So it's saying that.
Well, these are the types of the holes that you have in your program.
Yeah. So some we got lift, whatever that is, of.
Yes.
Thing.
So I think if you type refine and then refine again, it's gonna fill what you need. Oh, it's not in scope. So I guess you'll need to import it.
But it was in scoped here.
Yeah, that's surprising. I think that the TT that's in scope here, it's already lifted somehow.
So if it was so I may be able to say to Agda, oh, I know what's going on here. I'll write TT in here.
Yes, and then you type refine. Yeah. Oh, sorry. Comma space is to accept what you wrote.
Oh, comma space. It's not. It cannot refine.
Okay, then we will try to pattern match on X. So you can do that by writing X here.
Right. Yeah.
And then comma C to make case, I believe. Can you split?
Yeah, because X can be anything, I think.
Oh, right. This is annoying. This is annoying. So try to wrap. So
I realized it didn't change the size of the font. Sorry.
Right. So try to put a left brace on the left of the X.
Yeah.
On the left of the X.
This one.
Yes. And then a closing brace just before the next parenthesis.
Oh, the whole thing. Okay.
Yeah.
Yep.
And then try the comma C with X in the hole again. See if it now works.
X. C.
No? Okay. Then I guess
it's a bit too complicated.
That's yeah. Okay. I thought this would work. Let's try to write REFL instead of X.
Yeah. X can be anything, right? So you can't split it.
But what confuses me is that if we try TT here, it doesn't accept it, but it accepts it in the previous code that we commented out. Yeah. So that part is. So I thought the REFL was the responsible for this. So can we try to write REFL instead of X and see if it works then?
In here?
No, in the parameter X.
Right. So we give it a. So get rid of the curly. Get rid of the braces.
No, you keep it.
Okay.
Okay.
Yeah. And
And
let's
then
try again. Oh, do. No, do.
and then write TT manually.
Yeah.
And then comma space. Try if it accepts it. No,
We're missing lift.
but that's surprising, no?
Okay,
Yeah.
so let's something fishy's going on. Let's make sure this worked.
I think you're missing the MK double arrow here.
Oh, I am. Yeah. It does work.
Okay. Interesting.
Right. Maybe try it with the import. Just the in. If you think, oh, these are now all right. So if I went to this and I said, what was it, comma space? Oh, it now works.
You needed to load the file before.
Oh, okay.
Right.
I thought I couldn't load it before because I couldn't load it before because this wasn't defined.
There we go.
It was failing to load because there was no symbol called new one. There's no body.
Okay, so now let's try without the referral. Does it work if we write an X there?
If I write in X and then the whole,
okay.
then what do I write?
And
Refine?
then
No,
because this is you'll need the import for this. But if you write TT and then comma space after loading,
Yeah.
Let's see if this works. Okay.
Yeah.
Yes.
Oh. Okay.
Well, it's unfortunate that this T is not the constructor because then it would work more automatically. Yeah. Well, you can do the same for the rest of the.
But this one. Oh, hold on a second. But this. I need a referral here or something.
Do you?
No.
Oh, this is just so. This is not rep. This is just the name. This is just the bound.
No. This is the constructor, but you don't need to pattern match on it. Like in Lean, we didn't use the hypothesis. So here, well, I mean, you're free to pattern match on referral, or you can leave it as an underscore if you want.
Okay.
Because it's not being used. So can you, instead of typing referral, can you try refine and see if it works?
Yeah.
Okay.
Nice.
Okay.
And then, refine.
Yeah.
Refine.
That's weird. Why is it not? Is it because it's the last one? It doesn't need parentheses.
Yeah.
Okay. And then here it can't. No introduction forms found.
So what is the need that you need to provide? What is the type of the hole?
How do I find that out?
I believe it's comma dot, but I'm not sure. No.
If I reload the file, maybe?
Yeah.
There we go.
Okay.
Something of type referral.
Referral equals X. That's weird.
Also,
But then I should be able to, don't want to pattern match on X and it can only be referral or something.
Oh yeah. Let's
Can I do that? I'm typing comma C. That's not. So can I?
So if you need to pattern match, you need to add the braces.
Right. Yeah. Oops.
And then you need to write the X in the hole.
Right. Yep. Oops.
And then try comma C. But it says
because this has referral, the wrong type.
So I think for this Can't you
Maybe.
replace x with refl, and then it's going to ask you to show that refl equals refl, which is refl.
Yes, we're trying to do it with magic key bindings.
Yeah, we're trying to do it with without thinking. If because up to now all I've had to do is type comma r, comma r, comma r, comma r, comma r, and then I've got the last hurdle I've got to think.
Oh, that sucks.
Yeah.
Yeah. So, no, we're trying to embrace the age of AI. We don't want to think anymore.
Yeah,
exactly.
Okay. I'm on board. Let's go.
Well, like in Lean or Cog, we just write simp or like refl or with reflexivity or whatever. What's the? But maybe we have to think of this last one. So I'd have to write refl here.
Yeah.
So
but
if I was looking at this, I'd look at say like, well, if x is refl, then I can put refl on the right hand side.
Yeah. But let's try something. Let's try something else. Can you remove the x in the hole?
Oops. Yeah.
And then type comma c. I'm not sure if it's gonna. And then x.
Ooh. Yes,
I think something went wrong.
Yes, let's try again.
Try again.
So what did it want me to type?
Comma c.
Comma c.
And then enter.
Pattern variables.
Let's see.
Empty to split on result. No, it just
didn't
do anything.
Try with x now.
Yeah. So I'm definitely in the thing. Press X.
Okay.
Worked.
Whoa.
Yeah, so
whoa.
So you can say that. So what did I can't even remember what I did. So I did so I'm in this state, then I load the file, and then a case split. But then it's saying pattern variables to case. So if you split on result, it's splitting on what? The type
I'm not sure
of the whole. But in any way, I can just give it the thing to pattern match on.
Yeah. There we go. And then next,
can just refine.
Yes.
Okay.
Okay, so we were a bit slow because I didn't remember the key.
Yeah. Well, it's fine. Yeah.
I think if we just do it again, we can just press.
Yeah, let's try the magic trick.
Like monkeys.
All right, so let's try that again. So
well, you need to provide the initial function. You need to provide that.
Oh, what, Jan? I need to provide the initial function? That's terrible.
If it was a constructor, you wouldn't need to do that. However,
but I can just put one. I don't need to put 4 question marks, do I?
No.
No,
it will not be able to. So if you put a question mark, you're telling it apply this function to exactly one argument.
Okay.
So if you want to generate the holes automatically, you need to create a hole first and then write this function inside the hole.
Oh, got it. So I put question mark here. I have to start.
Yeah.
Then I need to get that. Yep.
Yes, exactly. And now refine.
Nice. Fine. And
well, this is the tricky case because TT is a function, it's not a constructor, so you cannot use refine, unfortunately. You need to write it explicitly.
Okay.
It was fine.
It was fine, yeah. So you refine first to create the lambda, and then you need to provide TT.
In the hole. Yes.
Space, comma space. Yeah.
And for the rest, refining should be enough.
But the last one we need the case split.
Ah, that's true. Yeah.
So refine. Good.
And the braces. That's a bit annoying. That's annoying.
Yeah.
To be honest, I still don't understand why they have 2 lambdas. There must be a reason.
Right. So let me load that again.
Yeah, you need to load that first.
Right. Then case split X. Okay.
Nice.
Nice. So what was the question, Jan? You didn't understand why.
So in Agda, unless you add the braces, you cannot pattern match on the variables.
Mm-hmm.
And well, I found it annoying that you need to add the braces manually.
Yeah, yeah.
And I'm not really sure if there is a reason. Like, is it only like syntax, or there is a deeper meaning to the lambda without the braces? I'm not sure.
Right. Is this just like the simpler form of the lambda?
Well, that's the part that I don't know. Like, I'm not sure if this is semantically equivalent to the lambda with the braces, just with a different syntax, or if it has a slightly different meaning.
Okay.
I would say it's the same, but I'm not sure.
I think it's the same. I think the one just no, I don't know.
So if you don't add the
right for us, so it might just be like that's how we inferred it. We had to go manually put the parames there to get the inference. So for someone who wants to reproduce this, they can't just use refine. You have to generalize at that point. Like you had to go manually put parames there, curlies. Now I'm using it wrong. You have to go put the curlies there. That's why we keep it there. To show someone who wants to reproduce this.
Mhm.
That's my guess.
But then in here, the other ones, we're okay because we don't have to pattern match on the X. We don't have to use the curly brace version. We just have a named argument.
Yeah.
The lambda. But yeah, it would be nice if you're doing this refinement business, then you're probably going to case match.
Exactly.
Or maybe that's just me being biased on my one-time experience of doing one problem.
No,
I want it to be convenient for me and want exactly what I'm doing right now.
I've had this problem many times.
Okay. Yeah.
Okay.
Right, so what's the equivalent of doing all this in Lean then?
Well, this
So
is
refine is
just before we move on. If you command click on the NK thingy,
go to definition or
go to definition, whatever.
Okay.
Yeah, sorry.
Yeah.
So what's interesting here is this is not just A goes to B, and it's not just A implies B and B implies A. It also says that they're inverses of each other.
Yes.
So yeah, I wonder if basically the proofs I've laid out don't have this requirement to prove inverses. So this is something we'll probably add later. But can we click on inverse just to see?
Oops. I mean what was I?
Yeah, we go down whatever.
Yes, this is a left and right inverse.
Yeah, can we click on one just to?
Is this twiddle one?
Yeah. So this is just
So it's just G, F of G is equal F of
Yeah. Okay. What is twiddle?
Right inverse.
Yeah, fair enough.
Twiddle is here, this constructor.
Can we go down to twiddle one?
Oh, twiddle one.
This is a parameter to the module.
So it's a relation, I guess.
Yeah.
Just a
heterogeneous binary relations. So I guess we've got our binary relations going to be some kind of equals. So we
Okay.
I don't know where we see that, but
Okay.
here we go. Here we go. I guess this is the
So if you go to A
Conc.
should be a setoid.
right, and we can see what the equality is on the set for the setoid.
Oh, oh no, A is a set. Okay. So where is the propositional equality given?
Is it inferred from this?
Yeah,
Whoa, look at this.
Whoa.
Love it. This
Could
symbol.
be. Amazing.
We got
Right.
this
I think it's inferred because we give the, the triple equal.conc.
Yes, I think it comes from here because this is the
Yeah.
Okay.
so it's
what is
actually
the equal Kong?
yeah.
Yeah. So this is propositional equality.
Okay.
So it's just left and right inverse, but with
Okay. Okay. So yeah.
But yeah, you're right. We're not checking that, I suppose.
Yeah, but it's okay. I'll add it later. Let's do the part of the proof that's like prepared and see how
Yeah.
the Agda and Lean differ for just that part at least.
So we've done. Oops, am I in the right place? Yes. So we do this. This is like writing the function name, I guess.
Yeah.
AB.
Intro A is just the X, and then P unit is TT.
Exactly. So here we didn't need to name anything because we just want to yeah, it doesn't matter what this H is. This is the reference here.
Yeah.
This is just the X in our thing before.
Exactly.
Right. And then
I think this is intro H or intro X.
Yeah.
And then I'm gonna guess this is a rifle.
Yeah.
Trifle, sorry, trifle.
Trifle. I just spelled trifle.
Maybe I spelled trifle incorrectly.
No, I just unknown tactic. So we got
exact, try exact.
Oh yeah.
No. Okay.
Yeah.
Oh, sorry. You could just
because it's a function, not a tactic. Yeah.
You should just write RFL. Sorry, not the.
Yeah. Oh, I did that. I maybe didn't give it.
Yeah. Okay. So what's wrong?
This is a case where the trifle wins.
No, a trifle didn't work either.
Okay.
Did it?
I thought I didn't get any squigglies.
But with exact it did, yes.
Yeah. It was this trifle wins.
Go down one. And then just go down.
Yeah.
Oh wow. Okay, that's a problem.
So we need to that's one thing to understand is why is the power of the trifle.
Yeah, that's some amazing trifle,
Yeah. plenty of
yeah, that's it, right?
spice. Yeah, that's it, because we haven't got these obligations. So it's not Agda's fault. It's our definition of if and only if.
Yeah. Yeah, and we can copy this and do it Agda's more Agda style.
Okay.
Just copy and make a version with a tick.
Mm-hmm. Oops.
Yeah.
So here we just call the constructor.
We're not allowed to use tactics now.
But here we have the.
I think we first need a function that takes alpha.
In here.
Outside. Before.
Oh yeah. Sorry.
Fun.
Something.
Yeah, and then I think it's equal greater than instead of the colon equal. Equal greater than.
Oh yeah.
There we go.
Yeah.
And then now tough the intro, and then yeah,
We give it another function.
that takes nothing.
Again, this is just unit.
Yeah.
Oops.
Yeah. P unit.
Fun. P unit dot unit. Yeah.
And this, yeah, I think it's ignore and trifle.
Rifle.
And then yeah, equal greater
Oops.
than.
Yeah.
And then that should be it.
This is the Jupyter
Yes.
virus.
I know. I think I'm writing. Am I writing Jubix, Haskell, Agda, or what the hell am I writing?
Yeah.
Okay.
Yeah. So this is yeah, kind of.
But this is like it's funny, isn't it? How Agda is more like writing this than this, even though the result ends up looking like this, because the if you write it in this way, you've got to keep track of everything yourself. So you have to know where you're going.
Yeah.
Where in like tactics or in Agda refinement mode, you don't need to know where you're going. It kind of goes ahead of you. Well, here you've got to do all this.
Yeah, that Agda refine thing is pretty amazing, because you still get tracking of the goals below, but at the end you're just writing code. Well, it's very eye-opening to me. I didn't know about all of that. Yeah. Want to do another one?
You try.
I want to see this in Agda, because I know.
Okay, let's do it in active.
All
right, I need to figure out
the
copy this one.
I think it will be more interesting. I'm pretty sure we can figure out the lean one on our own. But
well, look at this guy.
Yeah,
it's gonna So oh no wait.
Yeah, no.
The mistake for number one, I need to give it the name.
Yeah.
So what would I do? I would look at the type of this thing, and I would say, well, I've got this thing.
You see
I've
that
got this if and only if.
You see
oh
that
yeah. Oh, indeed. Sorry, I don't need to go up there. So I'd see this. Can I go to definition on that?
No, unfortunately.
Because in order to know what to type here, I'd have to look up this definition, I suppose.
Yeah.
And so I jumped to that definition. I'd look at that, find the function I want. So I have to know that part.
Yeah, but In Lean, jumping to definition on symbols and cock, this is also not great. So
No, but I'm saying in yeah. But do that.
Mm-hmm.
Do that. How far can we now we get into this lift business? Because I didn't.
Can you load?
Yeah. Yeah. So now it's lift L data.empty.bottom.
Right. So if in your goal you have empty, it's like a hint that you either derive empty from your arguments or you're not going to finish the proof.
Yeah.
Or you find a bug. That's also possible.
Okay. So now I have to know
Mm-hmm.
that.
So what is the type of X when you refined it to be a lambda?
no, before you.
Can you load now?
Yeah.
And then go to the goal.
Yes.
And then can you try comma, comma? So there is a command that tells you the type of the things that are in
There we
scope.
go.
Okay.
Comma, comma. So X is, yes, X is bad.
X is suspicious.
So now we can do cases on X.
Let's try that.
Yeah. So this X.
Right. But let's try at the braces.
Right.
I'm not sure. Well, let's try it.
That's good.
There we go.
Nice. We need to add the braces. And it figures it out.
And now you can remove the braces, which makes no sense, but okay.
Yeah, those braces aren't there. They're just to show that you had to add them. They're
Yeah. Well, I like if it was like somehow configurable to say, well, I always want this form of the thing.
Yes.
Of the lambda.
Could maybe ask that in the Agda Zulip.
Yeah. And then these are different types. So this one might be different, but go forward. Oh no.
Yeah, that probably means we can prove anything. So
yeah.
So
yeah. And then this is the same, just with the
so Agda is quite good at figuring out when you have an empty in the arguments.
Oh, so it should be able to figure this out?
Like what I mean is when you press pattern match on X, it finds that you have an empty pattern, but I mean this is not entirely trivial because you have it under lift.
Yeah.
Or sometimes you have it under a tuple. So it must be, well, must be doing something.
Nice.
Does Agda have a formatter?
No.
No.
No,
the syntax is too complicated or people can't agree.
Yeah. At least not built into the compiler. Maybe there is like a third-party plugin or something.
Let's try that in Lean as our
Yeah.
final thing for the day. But that was pretty smooth.
Yes.
Let's just try simp. Let's just see if we get lucky.
Oh, there we go. I mean, this should be what I need the cheat sheet is like a discriminate.
I think it's contradiction. I think Lean only has one. But
No.
we first, unfortunately, need to intro and split. And
Oh, right, sure.
yeah.
What did simp actually do?
Not much. Sure, the contradiction is there.
Yeah, sure. The contradiction is latent. It's there.
So we can say apply diff.intro. I think that's kind of the usual way to do this. And then we can say contradiction.
Yeah, contradiction. No.
No?
Unknown tactic.
Oh, then it is discriminate. I'm wrong.
Yeah, one of those. Discussion. But the thing is, it auto-completed contradiction.
And it was highlighted as well.
But did it say?
We couldn't figure this out. Tactic contradiction failed.
Okay, that's fine. Okay.
Yeah. But look, we got. But this is
yeah. So the first just
we did intro. Yes.
Only looks at hypotheses. Like that's lame.
Okay.
Fine. Thing.
Oh, we've got empty here. So
yeah. So intro and contradiction.
If I intro this, yeah.
Yeah. There we go. So it's the same. I wonder how you do contradiction in. Yeah, can you print this one? Can you hashtag print this?
There must be like an elimination or something for. False elimination. There we go.
This false elimination is some inductive principle auto-generated, or I know it's not auto-generated.
Yeah.
Yeah, basically it takes false and returns anything.
Oh yeah, but it is an inductive principle from this. So you get this inductive thing generates a rec.
Right. Yes.
And then that's just a convenience thing, I guess. What we just saw, wherever I lost it now, but
well put. Well put.
Yeah. Oh, macro. Sorry. Oh no, macro inline.
Yeah.
Does that just mean inline? It doesn't mean this is a macro, does it? Can I click that? No.
Oh, that's. I don't know. I've worked with these annotations a bit the past few days. I don't know what they mean. They never do what I think they will, and I don't know actually where the documentation on them are. So because it's pretty advanced features, like you don't. So it's not really in the book as far as I can see, or any of the books. But yeah, so this looks not fun to write. It's a function that takes a variable.
You're talking about the thing we have
this
on
one
them,
here.
right?
Yeah.
Right.
So this is a function.
Copy that, and it's just see if we can like remove a lot of it to make it clean, because there's.
It's not even syntactically valid, is it?
Okay, great.
So we don't need this one.
Yeah, we can copy the first part from the previous theorem.
Oh, yeah. Sorry.
Just to be fair. Remove the by. Remove that line. And then I think instead of MP and MPR, we can do things. It is annoying that it's not simple.
Identity function, but this is
Oh, we don't need ID. So okay.
yeah.
No, I think we can get rid of that.
Well, this MP.
Yeah, and all of that. So we can do that with like a magic brace. The constructor brain. I don't know what you call that. The backslash greater than. A backslash smaller than, sorry.
Yeah, so this ID, what this MP, I don't know what to delete, because this is the argument to the.
Yeah, okay, so we can delete ID, we can delete the early, we can delete the MP, we can delete the
This thing.
yeah. Now we do back. No, back. Yeah, okay.
Oh, but this has no matching right brace.
Yeah, that's fine.
Yeah.
And then the NPR and the other equal as well. Yeah, that.
Ah, okay, I see.
Okay, and now we
put
the backslash smaller than.
Oh, right.
Yeah, and same at the end, just with a greater than. Yeah. So what's the problem?
It's got it has type. Oh, maybe I remove some of this junk. Invalid constructor, insufficient number of arguments. Where's it got this TIFF intro from?
Yeah, that's the
Oh, the angle brackets.
Yeah. We want that. I think we can underscore the A's.
Oh, that's 2 explicit fields, only 1 provided. I see 2. Oh, do I need to put space here? No. 2 arguments.
Maybe it struggles with funds.
Oh,
can you add parentheses around the fun?
Yeah.
Ah, all right. Yeah, that would make sense.
And the second one, just help it out a bit. Okay. Now we've tried.
There's 2 explicit fields only. I assume this means 2 and not some like reference to the second argument of something.
Yeah.
Who knows?
Okay. Make the second one just the under question mark A or something. And then let's do make it a by refine or something.
Just I have to put it in here. Can I put it? No, I can't go into tactic mode. Can I?
Yeah.
Function. Can? All right.
Absolutely.
Nice.
It is quite late for me. I think I'm gonna go have some dinner.
Okay.
Cool.
Thank you very much.
Thanks,
See you next time.
Yes. Thank you so much.
Bye.
Yeah, so question mark A. Yeah, we have to give it a name. Okay. Oh, see. Okay.
Well, what if I just get rid of it? Something's gone wrong here. Maybe they're the wrong brackets.
Okay, refine TIFF.intro.
Yeah. TIFF. Yeah, so now I should be able to do the
Let's quickly
fun thing with the false lim. Oops, exact something.
No. Oh, that too. But also
yeah.
And then that was weird. It was open paren before false. Open
Oh,
paren.
right. Yeah.
No. Before false.
Oh, before false.
Open paren underscore colon. And then after false.
Ilim.
Close paren after false. Dot ilim. Yeah. So that's what we had. Just
yeah.
Is it weird that we're not in case A?
Yes.
Right?
Yeah, well, what are we? Where are we writing this exact? What's going on? Do we get that way?
Put that whole fun in parens again, just for
This one, yes.
yeah.
Can we do a refine with the fun?
Yeah.
Like we would in Agda? We'll make it.
C.
Yes. Because now it's P empty one. So this we should just be able to use the false thing. What was the name of the
well, exact.
function? Yeah.
And then open paren underscore
What was this thing?
false. Yeah.
Well, what was the name of the thingy?
So we can't construct false.
This thing. But this is just false.lim, which is this.
Try that.
Oh yeah. Yeah, we can't. Yeah, no, this is no.
Well, we don't
provide a value of empty, p empty.
So for that, we did a sum on x. That's what we did before. So can you say false x?
Ah, right.
Oh, no, yeah, just at the end.
I don't need parens though, do I?
No.
But x is bound. Yeah, we lost. But no, x should be in the environment, right? Because we did a refine.
Yeah, what's the error?
Yeah, sorry. Application type mismatch.
What about
X
dot
not a thing though, is it?
Okay, sorry. Okay, what's the error?
X to argument. as type. Yeah, because it's the other.
I think p empty dot
So
11.
it takes a false and gives you a C, but we we want to say we don't have to provide anything because maybe we apply false elim.
What about p empty elim?
No.
Oh,
Now we can do no. Sorry, what was the suggestion?
p empty elim.
Ah. Exact.
Yeah. Yeah. What's the? Hmm. Okay, can we see the printout again?
Yeah.
Like A is never used.
So this underscore means that it's figuring out what it needs to be. Something of type false.
It doesn't care. It's just give me the false type. Well, maybe you're right. Maybe that is the key.
So
it is
go back. Whoops. What is the?
Well, our contradiction happens in X, right? You can do. That's the thing. Oh, I guess the stream stopped.
Oh, hello. Oh, the stream. We lost this. Oh, it did, didn't it?
Yeah.
We got an empty audience.
No, we're still on. We're still on.
Oh, okay.
Okay. All right, this is very interesting. I think we can try to figure this out for next time.
Yes.
Yeah, let's call it a night. And thanks everyone for watching.
Thank you.
And let me find that button again. Everyone okay to say bye? Yeah, good.
Everyone.
Okay. Bye-bye.
Bye.